You've heard the word a million times, right? Blockchain. But what is it really? I mean, beyond all the hype and the complicated jargon, well, it's a technology that's kind of quietly changing the world. And today we are going to break it all down, piece by piece. So let's get right into it.
First things first, let's start with a really big question. In our everyday lives, we lean on places like banks or governments to make sure everything's on the level, to build trust. But what if you wanted to deal directly with someone else anywhere on the planet with no middleman? How could you possibly be sure that a transaction is real and that nobody's trying to pull a fast one? Well, that is the exact problem blockchain was born to solve.
The answer, believe it or not, starts with a surprisingly simple idea. I want you to picture a special kind of accounting book, a ledger. But instead of being locked away in some dusty office, this ledger is completely digital. And not only that, an identical copy is shared and updated across thousands of computers all over the world. This simple but really powerful idea, well, it's the foundation for everything we're about to talk about. So let's dig into that core idea. At its absolute heart, blockchain is just a new kind of digital ledger. It's a brand new way to record and verify information that makes it almost impossible to cheat the system.
Now, this is a really key point to get your head around. We often think of something like Bitcoin as a digital coin, but that's not quite right. There isn't an actual file that is the coin. A Bitcoin is simply an entry in this shared digital book. It's just a record that says, hey, this address owns this much. The coin is just the record itself.
And this is where you can really see the massive difference. A traditional ledger is centralized. It's in one place, controlled by one person or company, which makes it pretty vulnerable, right? But a blockchain, it's decentralized. The copies are everywhere, and you can't add a new entry unless most of the people on the network agree that it's valid. This is exactly what gives it its incredible security.
Okay, so we've got this shared buck. Awesome. But how is it kept safe? How do all these different computers agree on what the truth is? Well, let's get into the mechanics of it. We're going to lift the hood and break down all the technical magic into simple, understandable parts.
First up, the block. A block is really just a container for new information. It's a list of the most recent transactions that have all been checked out and are ready to be added to the ledger for good. You can just think of each block as a brand new page being added to our ever-growing digital book.
And now for the secret sauce, the hash. A hash is like a unique digital fingerprint that's generated for every single block. It's created by a complex math function. And here's the crucial part. If you change even a single comma or one little number inside that block, the hash, that fingerprint, changes completely. It's an absolutely ironclad way to spot if anyone's been tampering with things.
And this is how it all comes together to form the chain. So, a new block gets created, and it gets its own unique hash. But, and this is the absolute genius part, it also includes the hash of the block that came right before it. This links them together, creating a chain. So if you wanted to change an old block, you'd have to change its hash. But that would break the link to every single block that came after it. You'd have to redo the entire chain, which is basically impossible.
Now with this super secure chain, we can do something truly revolutionary. We can have trust that isn't based on a person or some big institution, but on math and code. This right here is the power of decentralization.
You see, this ledger doesn't live on some central server in a company's basement. Its strength comes from being distributed. There are thousands of copies on computers, we call them nodes, all around the world. There's no single point of failure, and no single person who can just shut it down or control it.
So let's just put it side by side to really let it sink in. The traditional system, we put our trust in centralized institutions. The blockchain system, we put our trust in math, in cryptography, and in a shared, open process. It's a huge shift from trusting people to trusting a process.
Okay, enough theory, right? How does this actually work when you, say, send some crypto to a friend? Let's walk through the life of a transaction step by step.
Okay, so it all starts when you use your private key, which is like a secret password only you know, to authorize the transaction. This gets broadcast out to the whole network. Then, all those computers, or nodes, check to make sure your signature is valid and that you actually have the funds to send. Once that's verified, your transaction gets bundled with a bunch of others into a new block by folks we call miners. Now here's where it gets wild. These miners all compete to solve a really complex math puzzle. This is called proof of work, and it's what keeps the network secure. The first one to solve it gets to add the new block to the chain. And just like that, your transaction is a permanent, unchangeable part of the record. Now, what's so incredibly exciting is that this technology for creating trust and permanent records, it goes way, way beyond just digital money. Let's take a quick look at the wider potential here.
I mean, we're talking about using blockchain for things like tracking a product from a factory all the way to the store shelf, creating voting systems that are impossible to tamper with, managing our digital identities securely, and even representing ownership of physical stuff like a house or a piece of art in a digital form. But one of the most powerful ideas is something called a smart contract.
A smart contract is basically a self-executing agreement. It's a bit of code on the blockchain that just says, if this thing happens, then do that thing. A classic example is for payments. If a sensor confirms a package has been delivered, then the contract automatically releases the payment to the seller. No escrow, no bank, no person needed. It's trust, automated.
But hey, let's be real. Blockchain isn't some magic wand that's going to solve all the world's problems. It is really important to have a balanced view of its potential and the very real challenges it's still facing.
On one hand, its strengths are super clear. You've got transparency, you've got security through immutability, and its resistance to censorship. But on the other hand, there are some pretty big weaknesses. Transactions can be way slower than a centralized network like Visa. The proof-of-work system that Bitcoin uses, well, it eats up a massive amount of energy. And getting these networks to handle millions of transactions a second is still a huge technical hurdle to overcome.
So, what's the really crucial takeaway here? It's this. Blockchain is more than just a piece of technology. It's a social and economic experiment. It is a fundamental attempt to redesign how we establish trust, moving it away from human-run institutions and toward transparent, verifiable code.
Which leaves us with a really profound question, doesn't it? Historically, we've placed our trust in institutions, governments, banks. Blockchain offers a different path, trusting in rules that, once they're set, can't be easily changed behind closed doors. So as this tech keeps evolving, the real question we all have to ask ourselves is, where do we place our trust? In the state or in the algorithm? Thanks so much for joining me.